Welcome to Old School Chemistry. Today we're going to do the topic, deducing the ions in a binary ionic compound from its empirical formula. I have a few notes for you on this. First, you're going to take those subscripts and cross them back up. That tells you the original charge. Second, after you do that, always double check the nonmetal. Make sure that the nonmetal matches our charge from the periodic table. That will inform you if it's been reduced. Okay, we'll jump in and I'll show you this. Great example that they give us here, sodium chloride. Now, if there's no number written, you and I know is understood to be a 1. So I cross the 1 back up, the 1 back up. That means originally the charges were Na, 1 plus, Cl, 1 minus. Now, how did I know the positive and negative? Metals are always positive. They're your cation, and nonmetals are always negative. The anion, that's how I knew the positive and negative. Metals are going to lose electrons, nonmetals are going to gain electrons. Okay, so that was the example. Let's jump in and do the rest of these. We've got a silver bromide. So this is understood to be a 1 and a 1. Cross those numbers back up. That means our original charges were Ag, 1 plus, Br, 1 minus. Now I always double check that nonmetal to make sure the compound wasn't reduced. So let's take a look. Oh, bromine, 7 valence electrons. It gains 1 electron. Yes, that is correct. Bromine is a 1 minus charge. So here I can type in Ag plus, Br minus. Now on ALEKs, if it is a 1 for the charge of 1 plus or 1 minus, don't put the 1, just put the plus or the minus. And that's what I did right here. Ag plus, Br minus. Okay, good. Let's do another one. We have a gold fluoride. Remember when I said that? We never tell the reader how many atoms we have in the compound. It's understood you and I can do this. We can do the ions. Okay, so let's take AuF3. We're going to cross those numbers back up to find the original charge. 3 goes up there, and this understood 1 comes up here on the fluorine. We have Au, 3 plus. I know the metal's going to be positive. F, 1 minus. Okay, now let's double check that fluorine. And sure enough, fluorine, 7 valence electrons. Yes, that is a 1 minus. It gains 1 electron to get that full octet. So I can write here, gold was originally a 3 plus, and fluorine was originally that 1 minus, and I'm just going to write the minus on that. 3 plus. Okay, great. All right, we have a manganese iodide. Let's go ahead and cross up charges here. So the 3 will be the original charge on the manganese. That understood 1 original charge on the iodide. Mn, 3 plus, I, 1 minus. Let's double check. I find my iodide. It has 7 valence electrons. So yes, iodine, 7 valence electrons, gains 1 electron to get the full octet. It is that 1 minus. Okay, oh, and so let's write that down. We've got Mn, 3 plus, I minus. All right, one more. Ooh, this one, its technical name is manganese 4 oxide. I'll show you why. MnO2. So let's cross up those original charges. So originally manganese was a 2. There's a 1 right here, so I'm going to cross that up for the 1 on the oxygen. That would give me Mn2 plus O 1 minus. Now, double check the nonmetal. Oh, look at oxygen. Oxygen is 6 valence electrons. It gains 2 electrons to become isoelectronic with our neon to have that full octet. Oxygen really is a 2 minus. This has been reduced. When you cross up your charges and the nonmetal has a number, but you check it on the periodic table and it doesn't match, that means it's been reduced. This has been reduced. So we have to do just a little bit of math to figure out what the original charge was on manganese. Remember, this is just a ratio. So if I had to multiply 1 by 2 to get 2, you'd have to do the same thing here. 1 times 2 is 2. 2 times 2 would give you 4 plus. Now notice, 4 to 2 ratio is the same as a 2 to 1, that charge right there. So our original charges were manganese 4 plus and oxygen 2 minus. Often on this topic, there's at least one compound that's been reduced. Now, not always, but I would say 80% of the time when I've done this, there's at least one compound, and not more than one, but at least one compound that has been reduced. So always double check your oxygen. Now, you might be saying, why is it, Mrs. Love, that you double check the non-metal and not the metal? Remember, transition metals, and we also have a special 4 right here, tin, lead, bismuth, antimony, they can change oxidation numbers. They can have different charges. The nonmetals, though, their charges don't change. That's why I always look at the nonmetal. That's going to be what we compare to see if you've had something reduced. Okay, I'm so proud of you. Great work. If you haven't already, please like and subscribe. I will see you next time.